Hello everyone, you're welcome back once again. My name is Victor Digomo here, and in our classes we have been looking at circle and its properties, and then right away we are still looking at problems that are coming from circle and its properties. All right, if you have been in the previous classes, you see that we've been able to solve a lot of problems there already. All right, so in this class we want to look at this problem as well that is coming from circle and its properties. If you look at this question, it says calculate the area of the shaded part. If you were in the previous classes, all right, you would have seen the nature of the questions we've been able to handle there and the difference as it has to do with that and this one. Okay, they are not the same. There is discrepancies in them, and then I'm trusting God that if you have been able to study those questions and those when in those classes as well, you see that this will pose a different challenge altogether, and it will help you to balance up if you can be able to study all the classes and see what you've been able to achieve so far. All right, so solution. How can one be able to solve a problem like this? How can one be able to solve a problem like this? This is a circle inscribed in a circle. Okay, there is a smaller circle and there is a bigger circle. So if you know that this is called a sector of a circle, and you know that area of a sector is given by theta over 360 times pi r squared. So we can be talking about the bigger sector here. We can be talking about the bigger sector. Now, I have two ways to go about this. It's either I say, since the formula is going for both, I can say let, I'm just showing you a description of this. I'll go back to what I'm doing. Let capital R be radius of a bigger circle. So you can choose this so that your capital R is, of course, from here to here, will give you 13 cm. And then small r be radius of smaller circle, which will give you from here to here 10 cm. So you can have something like, since what we need to do to get the area of this shaded portion is area of the bigger circle, I mean the area of the bigger sector minus area of the smaller sector. This part that is not shaded is the smaller sector. This part that is shaded and this part that is not shaded makes up the bigger sector. So if we calculate the area of the bigger sector and remove the area of this smaller sector, which is not shaded, we cannot get the remaining will be the area of this unshaded part. I'm sure that explanation is taken. So alternatively, instead of passing through, you can use theta over 360 times pi r. Now, you know there is going to be, a subtraction. This will be pi r capital R squared minus theta over 360 times pi small r squared. You see what is going on here now? So that when you factor out theta over 360, then times pi, you now have in brackets capital R squared minus small r squared. So this can go. You can use this to do the calculation, or alternatively, you can do it one after the other, so that this can be where r equals to 13. So you do your normal calculation. I'm sure that is well taken. So here I'm going to have 120 over 360 times 22 over 7 times 13 times 13. Okay, I hope you know how the 13 is coming about. 10 plus 3. So take away 0, take away 0. 12 cancel itself, 1, cancel 36, 3. I don't think there's any other thing that can divide these things here. So we have 22 times 13 times 13 all over 7 times 3, which is 21. So you go to your calculation and check 22 times 13 times 13 is 169 times 22. 169 times 22. That will give us 3,718. So 3,718 over 21. Is it 21? Yeah, over 21, because we have 3 times 7 here, over 21. So divided by 21. Divided by 21. That will give 177 point approximately 177.1. 177.1 cm square. That's for the bigger sector. Then you can come back and say area of smaller sector, which will now be theta over 360 times 22 over 7 times 10. Okay, small radius there, 10 times 10. Okay, I'm sure that explanation is okay. All right, theta here is 120. Let me replace it. 120 degrees. So this will cancel itself, 1, cancel here 3. What again do we have here? So 22 times 100, 10 times 10 is 100, which will give us 2,200 over 21. Yeah, 2,200 over 21. 2,200 divided by 21. That's 104.8. This is 104.8 cm square. So you can now take the difference. Therefore, area of shaded part is here is yeah, 177.1 minus 104.8, and finally that is going to give us 177.1 minus 104.8. 104.8, 72.3. That gave us 72.3, 72.3 cm squared. I said alternatively you can use this. Okay, you can use this formula to still give you the same thing. So I'm trusting God that the explanation I gave here is good enough to help you to understand how to handle other problems that you may possibly encounter out there. We have not exhausted the examples we have and the problems we have. We still have many of them. Of course, we're still coming up in this topic, sector and its properties. Remember, we still have a lot. After these sectors we are talking about now, we are going to go over to arc, length of arc, and chord, length of chord, the chord theorems, and then length of chord, and the problems that are also around that axis will also come out, and then from there we now delve into circle theorems. All the theorems of circle, we are going to look at them one after the other with examples. So I don't think you can afford to miss our classes. Please, the best thing to do is to subscribe so that you can have access to these classes anytime. Okay, and then share to your friends out there and like our videos. And as you do that, you are helping us to be empowered to make more impact in the society. Thank you so much for being there.